Assalamualaikum everyone, and today I will talk about the design of flap and the effect to aircraft performance. So basically, flaps are type of high lift device used to increase the lift of an aircraft wing at a given speed. Flaps are usually mounted on the wing trailing edge of a fixed-wing aircraft. Flaps are used to lower the minimum speed at which the aircraft can be safely flown and to increase the angle of descent for landing. Flaps also cause an increase in drag, so they are retracted when not needed. Extending the wing flaps increase the camber or curvature of the wing, raising the maximum lift coefficient or the upper limit to the lift a wing can generate. This allows the aircraft to generate the required lift at a lower speed, reducing the stalling speed of the aircraft and therefore also the minimum speed at which the aircraft will safely maintain flight. The increase in camber also increases the wing drag, which can be beneficial during approach and landing because it slows the aircraft. In some aircraft configurations, a useful side effect of flap deployment is a decrease in aircraft pitch angle, which lower the nose, thereby improving the pilot's views of the runway over the nose of the aircraft during landing. And now I will tell you about how the four type of aircraft flaps work. And the first design of flap is a plain flap. The most simple flap is the plain flap. Plain flaps hinge to the back of the wing and they pivot down when you extend them. However, they are fairly limited in the amount of lift they can create. That's because as air moves over the wing, it loses energy and starts to separate from the wing. By extending flaps, the airflow separation is even more pronounced, creating a large wake behind the wings. But you can use that your wake to your advantage. The drag created by the wake lets you fly a steeper descent to landing without increasing your airspeed. And the second flap is a split flap. The split flap, which deflect from the lower surface of the wing. Split flap produce slightly more lift than the plain flap, but like their plain counterparts, they are also produce a lot of split flaps are pretty uncommon this day, but you can find them on the wing of several warbirds at your local air show. And the next one is slotted flaps. Slotted flaps are the most commonly used flaps today, and they can be found on both small and large aircraft. What makes them so special? There are two things. First, they are increased wing chamber like other flaps. Second, when extended, they open a slot between the wing and the flap. By opening a slot between the wing and the flap, high pressure air from the bottom of the wing flows through the slot into the upper surface. This adds energy to the wing's boundary layer, delays airflow separation and produces less drag. The result? Lots of additional lift without the excessive drag. And the last one is Fowler flaps. When you need serious lift, you need serious flaps, and Fowlers are there to make it happen. Fowlers flaps increase the area of your wing by extending out on rails or tracks. Fowler flaps often have a series of slots to add energy to the airflow as well. They are called slotted Fowler flaps. In the first stage of a Fowler flap extension, there's a large increase in lift but little increase in drag, making the setting ideal for takeoff in a large jet. As they continue to extend, the flap moves downward more and more, creating a little more lift but a lot more drag. So that's all the design of flap you need to know. So the benefits of the design of flaps is using Kruger flaps. So what are the benefit of Kruger flaps? These are the different type of Kruger flap used with increased efficiency coming at the cost of increased complexity. The simple one are basically flat panel that falls out from the wing lower surface into a very steep deploy position and seals against the wing leading edge. True, these are extremely simple, but they don't offer much in the way of stall protection. The next type has large folding bulb nose that offers increased performance at the cost of slightly increased complexity. This type of flap is commonly used in Boeing 727, 737 and inboard of Boeing 747. So in an economic way, this design of flaps provide lift of an aircraft lift, and currently the aviation industry are doing the research and development of the flap to help minimizing the cost and operating costs, and also provide efficiency to the aircraft in the future. So that's all for the video.